Have you ever forgotten to water your plant? Or maybe sometime you water them too much? What if your plant can take care of themselves? Well, everyone, I'm presenting to you guys a solution of that common problems, a plant assistant. The concept of this project is aimed to develop an automatic watering system that truly monitors and care for plant well-being. The system uses multiple sensors and multiple components to automate irrigation, alert the user, and display environmental conditions in real time. The first one, the soil moisture detection and watering. A soil moisture sensor continuously checks the plant soil moisture level. When the moisture level drops below the predefined level, the water pump is activated to water the plant. After watering process is complete, a buzzer will release a sound to notify the user that watering has occurred and is complete. So the second one is the water level monitoring. An ultrasonic sensor on top of the tank check if the water is far away from the sensor, which means it's running low. If the water level is low, a message will appear on the LCD screen to notify the user to refill the water in the tank. The system pauses automatic watering until the tank being refilled. And the third one is real-time environmental display. The LCD screen provides live update of temperature, humidity, light intensity, soil moisture, real-time clock, which help the user monitor plant need and plant environment so that we keep the plant in check. Let's take a look at the code description in the project. There's a three libraries that we there are four libraries that we adding. The first one is the Y to indicate initialize the I2C and for the DHT11 and for the LCD and for the RTC. Okay, let's continue. At first, we initialize the DHT11 with pin 2. We connect it with the pin 2 and for the LCD. We initialize the LCD at the address 0x27 with 16 multiplied with 2 characters. We did the maximum capacity and for the LCD that we're using. And the 16 is represent the column and the 2 over here is represent row. And for the RTC, we create the variable that we be using after that. It will be convenient for the coding, so we just create a variable named RTC. The product that we're using is the CS3231, which is the RTC real-time clock. And for the LDR, we define two things: the LDR pin at A1 pin, and the LDR digital at pin 4. And for the music, we connect the buzzer pin with the pin 6. We connect the buzzer with pin 6, and this function is named the play melody. Is the function that the sound that buzzer play when the watering process is complete. Yes, it look for time. When we enter the loop, the buzzer pin is low, which means the buzzer is on, and we delay to it. And then the buzzer is with too high, which means the buzzer is off, and we delay again to pause between the beep. It's like we have a gap of each sound, not continue the sound at the same time. And the next one is a toggle. The toggle is the function that in this project we need because we want to switch to show on LCD. We want to show light and moisture, but we have to toggle it. So we have to switch these two so they have enough space to display on the LCD. So we create the latest toggle time variable, which equal to 0 at the initial at the beginning. This is to track the last toggle it will be using right after this. So I will explain later. And the boolean for the show moisture, we set it to false at the beginning, and we use the logic that if it false, the show moisture. The moisture will not show, which means if it's false, the light will show at the LCD, and if it's true, the moisture will show at the LCD. And the timer, we create a counter and we set it to 0. This is the counter for loop. And for the LED, we connect it with at pin 7. And for the ultrasonic, we have an trigger pin at pin 8 and echo pin at pin 9 and variable name duration and distance. Duration is time that when the ultrasonic send the signal and it reflects back to it. And the next one is the moisture sensor. We create the water count to count that how many times that it detects that the soil is dry. And the next one is the relay. The relay we connected with the port, the pin 13. The relay is used for the water pump. If the LED at the relay is on, is green, so the water pump will activate. And let's continue with the setup. First, we will set up the DHT11. We will start the serial and we will start I2C. And for the buzzer, we will set the buzzer pin as an output, which means the pin that we connect at the beginning, the buzzer will work as an output. That the Arduino will send the signal to the buzzer pin, and buzzer pin will work as output. Okay, so at first we set the buzzer pin to be high to make sure it's turned off at the beginning, and we will start the DHT sensor after that. And for the LCD, we will start the LCD and turn on the backlight and clear the LCD monitors, and then we display on the LCD, the first row of an LCD with the word wait a minute to let the user know that it start running right now. And the next one is RTC. The RTC, at first we will have a condition if we check at the start of RTC. If it couldn't find the RTC one, it will print at the serial monitor that the RTC not found, so that we know that it can find the RTC. And the next one is the now variable. Is to read the RTC.now is to read the current time from the RTC and store it to the variable now, and it will print at the serial monitor that time that it read. Like for example, it's 12. It will be print if the time right now is 12. It will be print at the serial monitor that 12. Okay, so the next one is LDR. We set the LDR digital to be an input, so it will be received the data and send it to Arduino. And for the ultrasonic, the trigger pin is an output, so it will receive data from Arduino. And for the echo pin, it's working an input with receiving data and send it to the Arduino. And for an LED work as an output, and relay we set it to be an output. And at first we set it to be high, so it makes sure that it off at the beginning of the work, the project. And the next one, we were talking about the loop. The loop will be checking the temperature, humidity, and soil humidity every minute, every 60 seconds. It will check the DHT11, it will check water, it will check the moisture of the soil, and then every 10 minutes. It will be delay for it will be delay every 10 seconds, and the counter will increase. And this if condition, if the counter is larger or equal to 6, it will be reset to 0. So it will be reset every. This is what it means by reset every 60 seconds, because the counter couldn't be greater than 6. Yes. So it will check every minute. So to make sure that we have read it continuously. And the check water over here is not in the if condition or is not in any condition. So this is mean that we want to check water more often. Yes. And the next one is the DHT11. The DHT11 we have the T, which is it read temperature from an DHT, and the H is to read the humidity from the DHT, and the lightning is to read from an LDR pin. It's read the data from an LDR pin, which is over here. This is an LDR pin. It's an analog pin. So we use an analog read, and for the moisture is we use an analog read for at A0 to check a soil moisture. And this if condition is to check that the T and H, the temperature and humidity, is it a number? And this command is to check that if not a number, if it check that the temperature and humidity is not a number, it will print at the serial monitor that it failed to read from the sensor, and this whole code over here, it will be printed at the serial monitor. Let's continue with the LCD. The things that will be displayed on at the LCD for this whole code over here will be printed at the first row of an LCD. This is to check an hour and print, and this is to check a minute and print. It will be in this format, this kind of format. It's like, for example, this is how it will be printed on the LCD display. The first one is the time, and the second one will be the temperature. And we have this if condition over here to toggles the light and the moisture. We check the millis minus by the latest toggle time. Is it larger or equal to 5,000? The 5,000 is mean the every 5 seconds. The millis, it will start counting when the Arduino will start running, and we will use the start the data that we will receive from the start of the beginning minus with the last toggle value. Is it reach a 5 second? If it reach 5 seconds, so we will toggle. If it currently a light, it will switch to the moisture, and if it currently a moisture, it will switch to the light. And after each toggle is switched already, we will update the latest toggle time to that current value, so that it can be used at the next 5 seconds. Okay, and the next one is for the second row of the LCD. It will be print the humidity, and this one will be print humidity, and this if else condition over here, as I told you, that it will toggle every 5 seconds. So if it's not show moisture, so the light will be show at the LCD, but otherwise it's gonna be show the moisture on the display. And the next one is the ultrasonic sensor. The function, the check water. We check the trigger pin, and we use the delay microsecond to pause, to measurement, to wait and make a measurement. I mean, how it works is like the ultrasonic is put at the specific point and then send some signal to the water, and it will be calculate the time that that signal is sent back. So this is to find an duration. The duration is how to find a duration. We use the pausing echo pin high. We measure how long that the echo pin is high. The echo pin is work as an input, so it will be receiving the signal, and it will be stored in the duration, which is the time that it used for to go back to itself. So it meet the condition. If the duration is larger than 0, so the distance is the duration divided by 2, because we want it one-way travel. The duration is when it go and it back, but we want only one-way travel, so we divided by 2. And to calculate the distance is to time the speed of the ultrasonic speed, which is 0.034 centimeter per millisecond. So after it done calculating, it will be print at the serial monitor. And if the distance is larger than 12, which means the water is low, right? So it will be print at the LCD that to let you know that the water is low, so you need to refill the water. And over here, the LED will be high, so the LED that we set at an output over here will be on. So to let the user know that the water level is low, so you need to refill the water. Otherwise, if it's not larger than 12, so it remain low, so which means the LED doesn't on. Yes. The next one is the moisture sensor. Is to check the moisture of the soil, the soil humidity. The moisture will read from 0 to 1023, which means 0 to 5 volt, and it will be printed at the serial monitor to show that the moisture sensor value to identify the data of the moisture that they detect. And in this if condition, we said that if the moisture is less than or equal to 300, the water count will be increased, and it will be shown at the serial monitor that how many water count have been already count. So if it reach 5, the what called reach 5 is to make sure that the data that we read is real. So the watering process is activated and the water count is set to 0 when it's done watering. For the watering process is over here. The watering process, at first, we want to print at the serial monitor to let you know that the relay is on or not. So we print at the serial monitor that relay on and relay is low. The relay low is indicate the relay is activated, so the pump is working, and we delay. And then we check, okay, and then we print again at the, if it's done, we will print at the serial monitor that the relay is off, which means the water pump stop active. So it will be called complete watering, and counter will be increased. The counter is the counter that we use for count a loop. Over here, that counter for a loop is a timer. Okay, I just want to make sure about the watering. The concept is that we show at the we show the status of the relay at the serial monitor to let us know that, okay, right now the relay is activated, so we know that the water pump will be active and the watering process is performing. And if the serial monitor is show that the relay is off, so we know that the water pump is off, the watering process is complete, so we call the complete watering. The complete watering, as we mentioned at the beginning, when we finish the watering process, there will be a sound come out of the buzzer. So when we finish the watering, right, we will call the complete watering. The function complete watering will start with showing the LCD, that at the first row we will be saying thank you, and the second row we will show you some cutesy emoji, and then we will be playing the sound that we've been create these at the beginning over here. And then it means that when the pump is working, and I mean when the pump is done working, it will display the thank you on the LCD, and then it's done, and then the sound of music come off, and yes, and the counter is count up, and this thing over here is to clear an LCD. And also we continue to check the, after it's done working, right, we still need to check the EHT11 and then the moisture, and we will be display the moisture that we've been reading from the the device that we received the data from, which is help to refresh the LCD after watering.
Okay, I will take you to the circuit description. This is our circuit diagram, so you can watch the components of it more easily. We have sensor and LCD part, and then soil moisture and water part, so you can see the separate part of it. And then this is our real product of our project, and this one is our product in action. So you can see it kind of separately, the active doing part, and then the laid back showing the user part. Now I will walk you through the demonstration of our product. So here is our project demonstration. I will guide you through. Okay, let's go. This one is our main component Arduino. It will do all the code and send it to component. And this one is LCD screen. It show all the stuff. We have timer, temperature, humidity, moisture, and light. For time, we have real-time clock, so it know how long it has been running. Yeah, okay. And for the temperature and humidity, it comes from the HT11 sensor to observe the plant condition right here. To observe plant condition, if it's good or bad. Next, we have light. We have LDR resistor that receive the light and show the light index roughly. Here it will receive the light if it's good for plant. Next, we have moisture. That here it will come from the soil moisture sensor right here. It check for the soil moisture if it's good or dry. if it good, here it will keep observing and stay ready. And but if not, the soil will send to the Arduino, so it know it is dry. It will send to the Arduino that it is dry. Then the component will run. The relay will run together with 90 volt. It will start the water pump to suck the water from the water container into the plant. Yes, right here, into the dirt, and the plant will be happy. Then from the pump, we have the water container LDR. This one is auto sensor. It will check the water level if it's good or not. If it's good, the system will run normally and keeping standard. If it's not, I will demonstrate you that water is dry. Now it have no water. It cannot detect any water. Right here in the screen, it will tell you to refill the water, and then the LED light will light on to indicate user to refill the water. And then now we have refilled the water. The screen will come to normal and LED will turn off here, as you can see. Then next, I will demonstrate you when the moisture is dry. I will take out so it simulate the dry. As you can see, the moisture has come up a lot. Now I will wait for the cycle for the watering to start. Here it is. Yeah, there's the water. And then when it's done watering, it will notify that thank you, and then we have beep 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 beep. So the user will know that it has done watering. And when it's done watering, the plant will be moist and wet, and then it will be good again. And that's all the product. Thank you very much. Bye bye.